Hello friends, welcome back. In this tutorial we will study about reduced grammar. First of all, we will learn about useless symbols and useless productions of a grammar. Useless symbols are those variables and terminals which do not appear in any derivation of a string of terminals. Productions which involve useless symbols are called useless productions. The grammar we get after removing its useless symbols and productions is called reduced grammar. Language generated by reduced grammar is same as that generated by original grammar. There is a two-step procedure to obtain the reduced grammar of a given grammar. Step 1. Remove those variables which do not derive any terminal string and remove those productions which involve these variables. Now, how we can remove such type of variables and productions? Suppose a grammar G is given to us, right? And we have to remove those variables which do not derive any terminal strings and those productions which involve these variables from this grammar G. First of all, we will make a new set V2, right? Then we will add those variables A to V2 which directly derives terminal strings. It means those variables which have productions of the form A derives W, where W is a string of terminals. After this, we will repeat this step while V2 changes. Now, what we have to do in this step, right? Add those variables B to V2 which derives the string as B derives x1, x2, x3 up to xn, where each xi is either a terminal or a variable of set V2. It means we will add a variable B in V2 if each symbol of the right side of its production is either a terminal or a variable of set V2. It would be more clear after this example. Suppose there is a grammar G whose productions are these one. S derives AA, S derives BA, S derives CC, S derives AD, A derives ADD, A derives BC, B derives AB, B derives CE, C derives C, D derives D. Right? Now we have to remove those variables which do not derive any terminal strings and productions involving these variables, right? First of all, we will make a set V2, right? Now add those variables to V2 which directly derives terminals. So variables C and D will be added to set V2 because they directly derives terminals. C derives C and D derives D, right? So first of all, what we have to do, we have to make a set V2 and we have to add those variables which directly derives the string of terminals. Right. Now set v2 has two variables c and d. After this, we have to add a variable in set v2 if and only if each symbol of the right side of that variable's production is either a terminal or a variable of set v2. Right. Now, see the variable a. Right. A derives the string of terminals and those variables which are present in set v2. So we will add a to set v2. Right. Now v2 has three variables a, c and d. Now again see the productions as derives AA, as derives BA, as derives CC, as derives AD. As derives the string of terminals and those variables which are present in set v2. So add S to set v2. Right. Now v2 has four variables a, c, d and s. Now there is no variable left which can be added to set v2. So the variables which are not present in v2 are useless. Here b and e are not present in set v2. So they are useless and should be removed. And productions involving b and e are also useless. So the production b derives ab and b derives ce should also be removed. After performing step 1, right, we will perform step 2. In step 2, we remove those variables and terminals from grammar which are not present in any string which is derivable from start symbol s, and remove those productions which involve these variables and terminals. So how we remove such variables, terminals and productions? Suppose a grammar G is given to us, right? What will we do? We have to remove those variables and terminals from grammar G which are not present in any string which is derived from start symbol s, and we have to remove those productions also which involve such type of variables and terminals. So first of all, we will make two sets, v3 and t3. v3 will contain only one element s, and t3 will be an empty set, right? It will not have any element. Now we have to repeat this step while V3 and T3 change. For every symbol A in V3, if A derives alpha 1 and A derives alpha 2 and A derives alpha 3 up to A derives alpha n, then add all variables in strings alpha 1, alpha 2, alpha 3 up to alpha n to set V3, and all terminals in strings alpha 1, alpha 2, alpha 3 up to alpha n to set T3. All variables and terminals after this which are not present in V3 and T3 do not appear in any string derivable from S. So all terminals and variables which are not present in T3 and V3 are useless, and productions involving them are also useless, so they should be removed. It would be more clear after this example. Suppose there is a grammar G whose productions are given here. Now we have to remove those variables and terminals from this grammar which are not present in any string derivable from start symbol S, and we have to remove those productions also which involve such type of variables and terminals. Now first of all we will make two sets, V3 and T3. T3 is an empty set and V3 contains start symbol S. Now see the productions of variable present in set V3. Here only one variable is present, that is S. So see the productions of S. S derives A, B. S derives B, A. So add the variables A, B to set V3 and add the terminals A, B to set T3. Now see the production of another element or another variable present in set V3. So now see the productions of variable A. A derives A derives B, C, A. A is already present in set V3. Add C to V3. Terminals A and B are already present in set T3. Now see the productions of variable B. B derives C, A. B derives A, C. Variable A and C are already present in set V3. Terminal A is already present in set T3. Terminal C is not present in set T3. So add terminal C to set T3. Now see the productions of variable C. Right? C derives A, B. C derives C, B. Variables A and B are already present in set V3 and terminals B and C are also present in set T3. Now we have seen the productions of all variables present in set V3. Now we can't add any variables and terminals to set V3 and T3. Variables and terminals which are not present in set V3 and T3 are useless, and productions involving them are also useless, so they should be removed. So variable D and terminal D are useless. Variable D is not present in set V3 and terminal D is not present in set T3. Production which involve them, that is D derives AB and D derives DB, are also useless, right? So remove these productions also. So these are the two steps, step 1 and step 2. First we have to perform step 1, then step 2 to obtain the reduced grammar of a given grammar. Thank you very much.